All right, welcome to part 2 of 7.1. Now we're going to look to find the area of the region bounded by y equals negative x, y equals the square root of 2 minus x, and the x-axis. This is unusual because you're given three functions. Technically, the x-axis is y equals 0. So if I were to graph y equals negative x, that's this line. Y equals the square root of 2 minus x. Again, if you have to go to your calculator, do so. That's this curve. And then the x-axis, well, that's going to be our boundary right in here between 0 and 2. So whenever you have three boundaries, it's pretty good chance you're going to have to come up with two different integrals. Because if you notice in my picture here, the blue is the top curve for everything. All right, but to the left of the y-axis, the red curve is the bottom curve. And when we get over here to the right side in quadrant 1, the x-axis is our boundary here at y equals 0. So far, we have an intersection point at the origin. We can see an intersection here at 2, 0. And just to make sure, I'm pretty sure that's at negative 2, 2, but I'm going to go ahead and check anyhow. So red curve, blue curve, set the two x expressions equal to each other. I have to square both sides. And something strange is happening here. When you square both sides, notice the left side went from negative, right side's positive, and now they're both positive. When that happens, there's a change in signs, and it's not on both sides. You're probably going to create what's known as an extraneous solution. So it's quadratic. We set it equal to 0. We factor it. We solve it. X equals negative 2. Yes, that's that intersection point there. But 1? What? There's no intersection between the blue and the red at 1. Again, this is the point that was false and became true. So if you take the 1 and check here, that's negative 1, square root of 2 minus 1 is 1. Negative 1 does not equal 1. That's false. But as soon as you squared it and you go to this statement, 1 squared is 1. 2 minus 1 is 1. It became true. So we have to throw that answer out. So we have two areas here. The one to the left over here in quadrant 2, we'll call that A1. That's going to be from negative 2 to 0. And area 2 is going to be from 0 to 2. And we're going to find each area and add them together. All right, here we go. A1, top function minus bottom function. We're going to integrate from negative 2 to 0. We're going to have the top function, the square root of 2 minus x, minus the negative x, which will become plus x. And I'm going to change my integral to this quantity to the 1/2 power. I'm going to change it to a fractional exponent. I'm now going to break this into two separate integrals. Reason being is because technically I have this square root function with an x to the first. They're not going to mingle very well. This is the problem, child. So what I'm going to do is I'm going to take you back to Calc 1 where you did your u substitution. I'm going to let 2 minus x represent u. Take the derivative of both sides. So I get du is equal to negative dx. But take that negative, divide it or multiply it over to the du. So dx will be replaced with negative du. And now I can put u to the 1/2 power right here. Now the next thing I want to do is I need to change my boundaries. So when x is equal to 0, my upper bound, you put 0 in for this x. 2 minus 0 is 2. My lower bound is negative 2. I plug that in, but I'm going to get 2 minus a negative 2, which is 4, which is kind of on the strange side, because now how can the lower bound be a bigger value than the upper bound? So the negative in front of my integral, that's the negative from my du. I just factored that out front. So since this is kind of strange, there is a quick fix. There is a property that you may recall back in Calc 1 that says if your integral is a negative, you can change it to a positive by switching your boundaries. Or if your boundaries are reverse like this, you can just switch them, but then make the integral a negative. So I'm going to do that real quick, and there's my integral. Now the whole time, the second integral, I haven't changed anything until I was ready to start integrating. So this one here, we'll add 1 to that. That'll be 1/2. That'll make it 3/2, and then you got to divide by 3/2, which is the same as multiplying by the reciprocal 2/3. Here we have x to the first becomes x squared over 2, or 1/2 x squared. Now we'll plug in and evaluate. Might need the assistance of a calculator here to do some simplifying. We're going to plug in the 4 raised to the 3/2 power. Well, that root of 2, the denominator of 2 is your root. The square root of 4 is 2, so we can call this 2 to the 3rd, which is 8 times 2/3. That would be 16/3. But then when you plug in the 2, that's a different story. We'll get 2 to the 3rd inside of a square root, so that would be the square root of 8, which you could simplify as 2 square root of 2. Multiplied to this 2 gives us you 4 square root of 2 over 3. Plus, we'll plug in the second upper bound here, 0 squared is 0, well that's 0. Negative 2 squared will be 4, half of 4 is 2, so there's upper bound minus lower bound, that's why there's a minus sign there. We'll combine like terms, so minus 2, we can make that minus 6 over 3, combine it with the 16/3, and we'll get 10/3. So 10/3 minus 4 square root of 2 over 3, we get 10 minus 4 square root of 2 all over 3. That's the area of A1. Now we got to go find A2. Top function, again, is this square root minus the green line, which is just y equals 0. So the minus 0, we can just get rid of that. Again, I changed it to 1/2. Now remember, real quick, I'm going to jump backwards here real fast. Here's this integral. Don't redo the work. Go back to where you integrated it over here and copy this over here. So same u substitution. All right, same rule for the bounds. Plug in the 2. 2 minus 2 is 0. Plug in a 0. 2 minus 0 is 2. Rewrite it. Okay, my bounds are backwards again. Flip them, makes it a positive. Integrate u to the 1/2 was u to the 3/2. Then we multiplied it by 2/3. Substitute in the 2. Wait a minute, that's the exact same value we had earlier when we plugged in the 2 for A1. So again, go back and check that value. It was 4 square root of 2 over 3. Plug in the 0, that's 0. So the area of A sub 2 is 4 square root of 2 over 3. So now we can add these two together. Well, that minus 4 radical 2 plus a 4 radical 2 will cancel these two out and give me 10/3 units squared. Now, what we want to do is say, holy cow, that was too much work. Here's another approach. Same picture, same points of intersection, but you're going to notice I don't have my green line down here. We can consider, instead of having a vertical representative rectangle, let's go horizontal. We can think about integrating this in terms of y, and instead of going top minus bottom, we'll go right function minus left function. And if you look at this green rectangle, it will always be touching the red and the blue curve all the way throughout the entire space. So left curve, right curve. Now we've got to make some changes here. If I want to integrate with respect to y, I have to take these two equations and solve them for x. So y equals negative x, okay, divide over the negative or multiply over the negative. The left curve is now x equals negative y. Right curve starts out as y equals the square root of 2 minus x. Square both sides. I'll add over the x, subtract over the y squared. There's my new equation. Now my boundaries, that's going to be from 0 up to 2. Now you look along the y-axis. Excuse me. So we're going to go right curve minus left curve. We're going to integrate from 0 to 2. The 2 minus y squared minus the negative y. Okay, that'll change this to a plus y. And again, I wrote this in descending order for the powers on my y's. And now we just have to do one integral. We don't have to do two. So we're going to get negative y cubed over 3, or negative 1/3 y cubed. We're going to get y squared over 2, or 1/2 y squared, plus a 2y. We'll substitute in the 2's. That'll give you negative 8/3 plus 4 over 2, which simplifies to 2, plus a 4. Minus, now we put in the lower bound, these will all be 0, so we don't even have to plug it in. So combine like terms, 2 plus 4 is 6, or we can say this will be 6/3 and 8/3, or excuse me, 12/3. Add this all together and we get 10/3 units squared. So consider that if you're given 3 boundaries like we did, think about, hey, can I look at this from the perspective of integrating it with respect to y?